So we're going to be spending quite a bit of time in this section. There's a lot of notes in this one, but we're going to break it apart into a couple of days. What we're going to start with first is actually really similar to what we were doing last week with our factoring. We're just going to be using that method now to help us solve a quadratic equation, which is why we talked about it. So we talked about factoring, we talked about FOIL last week, so that to kind of prep you for what would you use that for when it comes to a quadratic equation. So we're going to be getting into, in this section, how to solve quadratic equations by not only graphing it, but also by factoring. We're going to start today with factoring. We're not going to do any graphing for this first day. If you're trying to solve a quadratic equation, what you're basically trying to do is figure out what values could I put in for x in my equation that would get me 0 at the very end. Like if I actually plugged it all in, it would come out to be a 0. If those kind of things start happening, so if you're able to find two numbers that do that, so if you plug in a 2 and it's like 2 squared plus 4 times 2 minus whatever, and that equals 0, then you found a solution. There's of course going to be a lot of points that you can put in because we've seen that with ours when we were graphing them. Like before, when we were just graphing quadratic, we weren't necessarily looking for the solutions. We were just trying to graph it to see what it looked like. Now what I'm doing is looking for the solutions. Where, if I looked at the graph, would it cross the x-axis? Remember, the x-axis is that horizontal line on your coordinate plane. So when a quadratic equation crosses that line, that's where your x is 0, and that would be considered a solution. So one of the ways that we can do this is by factoring. And factoring is usually the faster method. Graphing takes a little bit more time. If we can factor it easily, then we would want to do that because it's going to save us a lot of time and it's going to get us our solutions right away. So this is going to, again, bring back to what we were doing last week. So for this first one, I have x squared minus 4x minus 12, and it equals 0. So really the only difference here is I've added on that equals 0 at the end because we're solving it. We're trying to figure out what x should be equal to here. So remember your rules from last week. You have to multiply to the last number of the equation, which would be a negative 12. And we have to add to the middle term, which is at negative 4. So we're looking for two numbers that would do both of those things. They both have to add to negative 12, or multiply to negative 12, they both have to add to negative 4. So the numbers that I'm thinking of would be 6 and 2. And if I have negative 6 times positive 2, I get negative 12. Negative 6 plus 2, I get negative 4. So those are your magic numbers. So then remember how we factored it is we dropped parentheses down. We put an x in each one because it's just x squared. Then one of them's going to have minus 6. One of them's going to have plus 2. The only difference here is that I have a equals 0 at the end. And what we do with that now is we take each piece that's inside the parentheses and we set each one equal to 0 now. And then we're going to solve for x. So we're going to set x minus 6 equals 0. And then x plus 2 equals 0. So go back to how you guys solved equations in algebra. When you're doing a one-step equation like this, you just do the opposite of the sign that you see. So for this first one, I have minus 6, so I need to add it over to the other side. So one solution is going to be x equals 6. The other one, I would subtract 2. 0 minus 2 is going to be negative 2. And there's the other solution. So if I graphed then, I would have one at like 6, 0. So I would go to the right 6. The other one I would go to the left, negative 2. And that's where, if I graph the rest of the quadratic equation, and like if I knew where the vertex was or other points, I would graph those and I should see that this is opening up and it's going to go through those 2 points. It's going to cross the x-axis at 6 and negative 2, and those are my solutions. So we're just taking this factoring one step further by actually setting them equal to 0 and solving for x. We're solving the equation now. So let's take a look at the second one. We have x squared equals 6x minus 8. For one like this, they don't have it written in the correct order. You need to move everything so that it's on the same side of the equal sign and have it be set equal to 0 instead. So I like to keep x squared positive because it makes it easier on you, so you don't have to worry about that negative x in there. So I'm going to subtract the 6x over, and I'm going to add the 8 over. And I'm going to do both of those. I'm going to move it to the other side. So it's now going to say x squared minus 6x plus 8 equals 0. Okay, so I want you guys to take a minute, factor this one, and then solve it. After you've got it factored, set them equal to 0 and solve it. Okay, so I'm looking for two numbers that multiply to 8, add to negative 6. What two numbers do that? Good, so negative 4 times negative 2 would be positive 8. Negative 4 plus negative 2 would be negative 6. So when I go to factor it, I'm going to have x minus 4, x minus 2. We have that set equal to 0. Now we set both of these up, so set up your two equations. X minus 4 equals 0. X minus 2 equals 0. So what did you guys get for final answers? Good. X equals 4, x equals 2. Okay, let's take a look at the third one. So we have 9a equals negative a squared minus 18. So again, to get this one started, we need to rewrite it. We got to get all those terms on the same side of the equal sign. Like I said earlier, I like to keep that x squared term positive if I can. So I'm going to add a squared and add 18. I'm going to move these both over to the other side. So the a squared is going to come first now. Then you have that plus 9a that was already sitting over there. And then it says plus 18. And that's equal to 0. Okay, take another minute or two and solve this one. So what do I need to multiply to in this problem? Like if I'm sitting in my chart, I need two numbers to multiply to what? 18 and add to 9. What numbers do that? Good. 6 times 3, 6 plus 3. So when I factor it, a plus 6, a plus 3 equals 0. Set both of those up. A plus 6 equals 0. A plus 3 equals 0. So what are the two answers we should have gotten? Good. Negative 6, negative 3. Now for number 4, this is going back to, again, we have to rewrite it like we've done on 2 and 3. But we have a number other than 1 sitting in front of that squared term. We have a 5t squared. This is going back to those ones that we had to factor out the longer way, where we had to take our a times our c. So we're going to do this one together. What I would do first is move, and I'm going to move the 12t to the right and the 9 to the right. So I'm going the opposite direction, again, because I want to keep the t squared term positive if I can. So now it says 5t squared minus 12t minus 9, because I would have subtracted those two terms over to the other side. Okay, now we got to do our a times c business, so we're going to take 5 times negative 9, which is negative 45. My b term, I leave that one alone. That's still going to be my negative 12. Now I use these two numbers to set up my chart. I'm going to multiply to a negative 45. I got to add to a negative 12. Anyone know what those two numbers might be? What would be 45 divided by 3? 15. So let's see if 15 and 3 work. Is there a way that I could add these and get a negative 12? Good. If I take negative 15 and positive 3, when I multiply I get negative 45. When I add I get that negative 12. So now remember, with these numbers, this is when we have to go and rewrite that middle term, that negative 12t. Because that's why we found those numbers, is to rewrite it so that we can end up grouping and then factoring. So please take that little bit of extra time. So we're going to do our 5t squared first. Then we got to write the middle term with the negative 15 and the 3. And it doesn't matter the order that you put it in. I'm just going to go ahead and do the negative 15t first. And then we have plus 3t, and then we have that minus 9. Now we group the first two and the last two together. What can I take out of the first two terms? 5 and a t. What would be left if I take those out? Good. What can I take out of the second set? 3. And remember, just like what we talked about last week, you want the pieces left in the parentheses to match. If I take a 3 out, I'm left with t minus 3. So far, good. Now we take the pieces sitting out front, so the 5t and the 3, those get stuck together. So 5t plus 3. And then the pieces inside the parentheses, you drop one of those down, so t minus 3. So that's factoring from what we did last week. Now remember, this is being set equal to 0, so now we have to solve it. So we're going to take 5t plus 3, set that equal to 0, and then t minus 3 and set that equal to 0. So for the one on the left side, 5t minus 3, we would start by subtracting 3. So we have 5t equals negative 3, and then divide by 5. You're going to get a fraction for this one, and I would just leave it as a fraction. So one answer is t equals negative 3/5. What's the other answer going to be? 3. We're just going to add that 3 over. Okay, we've got one more that we're going to do. So if you guys turn the page over, this kind of goes into the ones that we talked about when we were doing factoring at the very end of that section. We talked about like some special cases, some ones that you can still factor it, but they look a little different than the ones that we were doing where we always made those little t-charts where you had to multiply to this, add to this. We had some that it was like perfect squares, like the first term and the last term are perfect squares, and so we had like x minus 6, x plus 6. We talked about like the difference of two squares there. So sometimes you might have some that are special cases that don't require you to factor exactly like we were just doing it, and this would be one of them. So again, I'm going to move the terms so they're on the same side of the equal sign. I'm going to keep 2n squared positive. So I'm going to subtract 18n, move that over to the other side. So now it's going to say 2n squared minus 18n. And I'm going to go ahead and write equals 0. Now because this doesn't have a c term, c would be 0. So you could still do like your a times c and the b. You could do that all that stuff if you wanted to, but there's a faster way to do this one. Looking at these two terms, is there any number that I could pull out of both of them? 2. Do they share any letters? An n. If I take out a 2 and an n from each term, what's going to be left? Good. So this is considered factored form. And so what I'm going to do is take the 2n and set that equal to 0. And then I'm going to take the n minus 9 and set that equal to 0. Okay, so for this one, the 2n equals 0. To get rid of 2, we would divide by 2 on both sides. 0 divided by 2 is going to be 0. So one answer is 0. On the other one, we're going to add 9. And we get n equals 9. So if it looks a little different than those first couple that we were doing, see if you can put things on the same side and then try to group anything out if you can. See if it falls into one of those special cases, because it's going to be easier for you and a lot less work to do it this way than to try to go back and do it one of the ways that we've been doing before.